the Bohr model, and light. So within our last unit, we talked about how the sun produces energy in the form of light and heat through nuclear fusion. But how is this light actually generated? Well, the answer is moving electrons. We talked a lot about the nuclei, the protons and neutrons. We didn't discuss much about the electrons. So we know that nuclei combine, some of the mass is lost, and it's given off in the form of light and heat. How do we actually see it here on Earth, though? What is happening? And it's those moving electrons. The easiest way to talk about electrons that are moving is by using the Bohr model of the atom. And Niels Bohr explained how electrons have stable orbits around the nucleus called energy levels. So we have the nucleus in the center, and then within the electron cloud, we have different energy levels that an electron could be found in. Now, electrons that are in orbits farther from the nucleus have more energy compared to electrons found in orbits closer to the nucleus. So the farther away you are, the more energy an electron will have. Niels also realized that electrons could jump or fall from one orbit to another by either absorbing, taking in, or emitting, releasing, giving off energy. And their processes are different. So let's break them down. Energy absorption, taking in. We've realized that an electron must absorb or gain energy in order to jump into an energy level that is away from the nucleus. The amount of energy you absorb is directly related to how far away you can jump from the nucleus. So the more energy you absorbed, the greater the energy. The greater the energy you have, the greater the jump of an electron. So for example, if you take in a little bit amount of energy, you can have a small jump, where if you take in a large amount of energy, you can jump even further. The more energy you take in, the greater the jump. So how do we get this energy? Well, we can get it from heat, electricity, or light sources that can help move an electron to a higher energy level. This is what happened during the electric pickle. We added electricity to those ions, charged particles. So we added that electricity to those charged particles, causing the electrons to become excited. They gained in that electricity, caused it to jump. But they can't stay there forever. So what happens? Well, eventually that energy is going to be emitted or released. So when an electron falls closer to the nucleus, it is going to emit or release energy in the process. The greater the fall of an electron, the greater the amount of energy is being released. So, lots of energy, big jump. Lots of energy being released to have a big fall. So, if you have a small fall, a little bit of energy is being released. If you have a very large fall, a large amount of energy is going to be released. So as an electron falls closer to the nucleus, it's actually releasing the absorbed energy as light. So no matter how large the fall, if it's a tiny fall or a really big fall, energy is going to be given off in the form of light. Now, one thing to keep in mind, not all light is visible to our eyes. We'll talk more about that later. So the energy of light released is equal to the difference in energy between the two different energy levels. This means from where the electron started to where the electron fell. That is what determines the... Let's try that again. So the energy of the light released is equal to the difference in energy between the two different energy levels. The farther away from the nucleus it is, the more energy it has. So the difference between the energy level it originally was and where it fell to is going to determine how much energy light is released. Sorry. So when an atom, we're saying, is excited because it has excess energy, it will then fall. And as it falls down to a lower level, light, which we call a photon, is released. So one thing to keep in mind is each element has energy levels with different distances from the nucleus. Notice, hydrogen, the first energy level, is really far away from the nucleus compared to helium. The first energy level is much closer. Level 2 and 3 in hydrogen are very close together compared to helium, where the energy levels are pretty evenly spaced out. The farther away you are, the more energy you have. So it does make a difference. The amount of energy in hydrogen's first level is different compared to the energy in helium's first level. Hydrogen has more in its first level because it's farther away. Because the amounts of energy are different amounts of energy will be released when the electrons fall because they're different values. This is actually going to cause different colors of light to be emitted by each element. We'll talk more specifically about light and its properties and different waves and what this all means, but understanding that the different energies of the levels cause different colors of light to be emitted by elements. So, checkpoint. Let's talk it through. Arrows blank represent an absorption of energy. I'll give you a moment to answer your question. It says arrows, so there's two answers. Absorb, take in. In order to, when you take in energy, that's what allows you to jump. So it will be arrow, B and C. Because why? Think about it. Why? Yes, exactly. Because the electrons are moving away from the nucleus to a higher energy level. So when you absorb, you jump away. When you see arrows moving away from the nucleus, that means it has taken in energy to jump higher. Give you a moment to write down your answer. And remember, your words may be a little different than mine. All of our brains work differently. All right, arrow, so a single arrow. Which arrow represents the least absorption of energy? So we just talked about which ones show an absorption. The two absorptions are B and C. I want to know which one represents the least absorption. Go ahead and take a moment. Yes, the answer is B. B represents the least absorption of energy because, take a moment, think about it. Because you're right. The electron is only moving one energy level. We can see it's going from 4 to 5. Since it's only jumping one level, not as much energy has been absorbed compared to C, where it's going from 3 to 5. The bigger the jump, the more energy it has taken in. So we talked about absorption. Let's talk about emission. Arrows, so two arrows, which two represent the emission of energy? Go ahead, write your answer. Well, if B and C are the absorption, then A and D obviously have to be the emission. But why? Think about it. You're right. It's because the electron is moving towards the nucleus, down to a lower energy level. Whenever you have that electron falling towards the nucleus, it has to give off that energy. It can't take it with it. So when you have an electron falling towards the nucleus, it has to give off the energy. Emission. Last one. Arrow, so a single answer. Which arrow represents the greatest emission of energy? Go ahead. If you said A, good job. Why? Why does it represent the greatest emission of energy? Take a moment to think about it. Exactly. You're right. It's because the electron has the largest fall. It's the greatest fall towards the nucleus. It's falling from 5 down to 1. That's a lot of energy in level 5. It has to get rid of it somehow. If it's having so much energy that it needs to get rid of, it's going to release the most because it has the greatest fall. Arrow D is going from a very high energy level, but it doesn't have to get rid of as much of the energy just to go down to 4, because 4 has more than 1. All right. Go back and play anything that you need to that you may have missed, and the check-in for Bohr model and light will be posted shortly. See you later.